Good afternoon. Thank you.
Oh, that's perfect.
I can't wait start to touch this basic of Python. I know we still have a few examples left from the last class. If you check the lecture, you will see there's a couple of examples at the end of the slides. So I encourage you to go through by yourself for now. So at a certain time, I will come back. But I want to make sure first to proceed accordingly so you can do your homework. Okay. So today's plan is we will start touch a little bit of those Python basics. But then I will talk a little bit more about the environment, about the environment you need to do your homework, and probably how to practice at home. Okay, then we will enter further about more details about Python. Okay. First of all, before we talk anything about the first line of the Python code, how to do coding in Python. I guess this is what you like to know. First of all, I have requested each of you account at the Scholar cluster. Okay, so I will showing you some demo probably towards the later of this class to how to use this Scholar cluster to do your homework. But feel free to install on your home laptop or your home computer the environment to do the Python. It's the same thing. You can also do that. If you choose to install your own Python environment by yourself, what I suggest is to use this PyCharm. Okay, the PyCharm is a Python IDE. There's there's many Python IDE, but nobody complains about PyCharm. So I guess this is a very safe choice. So you can see here, this is one PyCharm interface. If you start the PyCharm, something looks like this. You can easily to write code there, you do some debugging there. But remember, Python is just a text, right? You can even using a text editor to write the Python code. But of course, the IDE will give you a lot of more convenience. There's another thing which is called Jupyter Notebook. I will give you some more examples about the Jupyter Notebook. Okay, Jupyter Notebook is one of the coolest way to play with Python code. Remember, you will use probably a PyCharm or any editor to write the .py code for your homework. The Jupyter Notebook is a concept I will explain later, used for classes, okay, and for your own practice. All right. For example, this is an interface of Jupyter Notebook. Use this, do your homework, and use this I will use this to demo in the class and for you to practice at home. All right. If you have nothing on your computer, you plan to install Python from scratch, what is the easiest way? I will suggest to go to the Anaconda. Anaconda, what is Anaconda? Is a package, is a Python package. It's one of the most popular package we use for data science. So you just go to anaconda.com and look for the download and then install. If you are asked to what version of Python to install, please choose Python 3 because we have Python 2, which is a little bit outdated. So we will choose Python 3. Okay, then you install, you will have Jupyter Notebook, you will have most of the toolbox we are going to use in this class. All right. By the way, feel free to stop me if you have additional questions. All right. So after we feel comfortable with the coding environment, so I want to show you a few slides of some Python basics. Then we will go to the environment again and make sure everybody feel comfortable to write your first line of Python code at home. Okay. First of all, for the variables, there's no definition or no declaration needed in Python. If you are from a C programmer, I'm sure, or a Java programmer, I'm sure you will start with your code to say int x or equal to 0, start to define a variable as a type. Let's say this is an integer, this is a float, this is double. Unless you define, you can't use a variable. But in Python, it doesn't do it in that way. We just use a way. We can start with x equal to 1. You don't need to define it. And then you can even change the type when you start using this. So of course, now I'm talking things in a little bit dry, but I will give you examples. So Friday, I will reserve the Friday as a demo section. I will try to show with a true code, the real code in Jupyter Notebook to demonstrate most of concept I'm talking. But now let's just listen and try to get comfortable with those concepts, with those differences. Okay. So you can start to say x equal to 1, then you can say x equal to 2.3. If you be careful, you see here, and we already changed the x from an integer to a float, but the Python is okay. And later you can say x equal to maybe quote, maybe name to convert to a string. It's perfectly fine. So Python is very friendly, allow you to do that. Okay, but there's a couple of rules to use to define the variable name. The first, you have to start with a letter or underscore. All right, so that means at least you can't start a variable with a, let's say, with a number, right? So you have to start your variable name as a letter or an underscore. So the reason why we allow underscore here, we will see more example later, right? You can put a underscore name, underscore name for a reason. One of the reasons is if you define that, you probably later, you don't want your people accidentally to overwrite some of the variables. That is one of the purpose. I will give more examples later in the course. Yeah, but remember, we have to start with a letter or an underscore as a variable name. All right. So it is case sensitive. So Purdue or Purdue with a uppercase P are two different variables. Okay, so basically we don't have many rows, but at least we have two rows for the variable name. All right, and this is a more try to create some kind of curiosity for you. We can use, let's say, the combination sign. The X can work on all type. If you add two string, you will concatenate two string. If you add a float to an integer, you'll get some arithmetic summation. Okay, so you may curious why we are able to use a plus sign on a string, on a number. I will later I will explain to you in the later of this course. This is come from the object-oriented property of the Python, because everything in Python is an object. So you can, by manipulating object, define different operations. For example, in the string object, I define my plus sign to have certain operation. Then for those integer or float, I will define my plus sign with another operation. But for you, what you have is convenience. You can use plus sign in whatever way you like, right? You can even define your own object to redefine your plus sign. So We will see all this later in the course. All right. Any questions so far? Then we have a set of different operators. Some of the operators will be very similar to those language you have already learned, but make sure, try to see the difference. Okay, so I will try to emphasize what's the difference from a MATLAB, from a C programming. Okay, so this set of comparison operator is more or less is what you expect, right? This is to, the first one is try to, let me bring some, anyway. This is try to say if A equal to B or not. Okay, so this is a comparison. What it will try to return is a Boolean, is a true or false. Is A equal to B? Then similarly, this is a if A is not equal to B. Also, if A and B are not equal, you will return a true, otherwise return a false. I think this is something very similar to other languages. Yeah. So this is obviously, this is a try to say A smaller than B or not. If A is smaller than B, you will return a true, otherwise a false. So this is a smaller or equal. This is a greater. This is greater or equal. Okay. I assume this is something pretty straightforward. With those comparison operator, okay, we usually use them in condition checking, right? So if condition, Y condition. So for example, we can say if R smaller than 3, then we will print X. So the print X will only be executed if the R smaller than 3. So R smaller than 3, this comparison statement, if it's true, then you will do this if statement. Okay, what you need to pay attention here is first, you will have this these 2 dots here to denote the starting of a block. Okay, and you can see we do not have this those curly bracket here. We are using a tab, a space. So if 2 dot, then you do a tab. Okay, so this tab will indicate this print statement is under the if condition. If in a C or in some other language, most likely you will say if R smaller than 3, you will put a curly bracket, right? Then you put a statement, then you put another ending bracket to define the block. But here we are using this white space to align those white space to define define those blocks. Okay. Let's see another example. We have keyword if, else if, else. All right. So as pay attention to the syntax, you will have these 2 dots here. Then you have this white space, and white space. All right. So the logic here is if something is true or not. If it's not true, then you check else if true or not. If not true, then else you do something. Yeah. So this is the basic logic here. Just feel free to stop me if, since now we are in person, it's even more flexible. Yeah. Just raise your hand or just try to ask questions. Okay. So anyway, we will see more examples. So don't worry if some of them does not give you a very good feeling. We will see more real examples, hopefully, and also you will do your homework. Yeah. So I'm sure after these few interactions, you will those will be your friends. Okay. Then we also have this arithmetic operator. Of course, this I don't need to mention. This is a summation. You have a manner take difference. This is a multiply. This is a division. But probably some people know this. This is a remainder, is a mode. Okay. But maybe this last two is something pretty mysterious to you if you haven't learned Python by chance. Okay. So the first one, this is a exponential. That means I want to raise a to the power of b. All right. So it's star, this two multiplication, that means exponential. A, so this is means a rate a with power to b. So this guy, okay. And what this? A backslash b. This is a floor division. Okay. Floor division, what does floor division means? Means you will after you divide, you will take the floor. You'll go toward the floor. Okay. That's for example, 1 divided by 2. If you do the floor division, what will be that? Will be 0. Yes, exactly. You take the floor of the of your the result. All right. So the assignment operator, I'm sure this is if you are, let's say, a C programmer, you have see something like this. Most of the like Java, you also have this. So this is a equal to b, but here is more. This is more assignment. It say I assign the value of b to a, right? So this is assign b, the value of b to a, and what does this? This is means I will assign the value of a plus b to a. So you will note here you are put a plus equal to sign. This is to say you will do the summation a plus b first, then assign the result to a. Okay, so this is a more shorthand to write a equal to a plus b. All right. Again, I don't know some of how good or how familiar are you with the programming language. So I assume you understand this assignment concept. So this is not equal. This is because if mathematically you see this is not true, right? Because a equal to a plus b mathematically doesn't make sense. But here is try this equal sign is assignment. Is to say I do a plus b, then I take that value, assign to a. All right. So this is a assignment. Okay. So similarly, this is a equal to a minus b. Okay. So you calculate a minus b first, then assign to a. But in shorthand, you can write a minus equal b. All right. Similarly, this is assignment version of a equal to a multiplied b. Then a equal to a divided by b. Okay. What I want to emphasize a little bit is a logic operator. In Python, the logic operator, we have to use this English name, English version. If we want to, here the a and b will be two Boolean variable or Boolean statement, right? And we want to check if a is true and b is true. We have to say and a and d. Okay. And if I want to check my condition is a or b is true, is basically one of them is true, we will use or. if I want to see the inverse of A, so basically if A is true, but I want to take the opposite of that statement or that variable, I will say not A. Or for example, you can put not A or B. The reason I want to emphasize we have to use the English and or not is because we are comfortable. I guess if you come from another language, you probably you are get used to A, like something like A and B, or A or B. Yeah, so if you don't know what I'm talking about, good for you. So you don't have this confusion. Yeah. So, but if you people, you already get used to use this kind of symbol, this is very, make sure you know this is not for logic. The worst part is actually in Python, we do have those symbols, but those are the bitwise operator. So if you put those symbols, probably you will get a return. And then unfortunately, that is not what you want for a logic decision. Okay, it's not a Boolean decision. It's a binary bit or operator. So pay attention to that. So the worst part is you write a code, the code running smoothly, but give you something which is not you design them for. Okay, so pay attention. So the next big chunk is to talk about 4 different collection type. So we will have a list, we will have tuple, we will have set, we will have dictionary. Okay, so probably I would, let me see. Tell you what, maybe I will move to the environment first, because we are going to release you the homework first soon, probably tomorrow or Friday. So I want to make sure you know how to check out your homework, how to start working. So anyway, I will come back to this list section. Okay. So one thing I forgot. By the way, I sent you guys emails. Do you receive my email? You're able to. Okay. So in case if people check your email, yeah, I use a Brightspace to sometimes send some message to you guys. So I send you a link, a YouTube, which is a unlisted videos. So last time I recorded, then I checked. It's not perfect, but still. For people, because I know there's people who have visa problem, who haven't arrived schools. Some people contact me, say what to do. So I think it's a good idea to record some of those videos. Yeah. It's an unlisted video, so people can't search for. So do not share the link. Keep those links to yourself. And also I mentioned there's one thing, very big information I forgot to mention is a programming assignment. Okay. We will do our program assignment, use the GitHub class. So what you need to do is you first need to register a GitHub account if you don't have. Okay. And second, by default, we do not know your GitHub account username. So you need to go to this place in your syllabus. Go to this place to provide us your GitHub account. Okay. So those TAs will try to link, well, based on what you provide there, we will link your GitHub to your actual, to your individual. Yeah. So this is important. And the second, since we are using a GitHub is what? Is a version control system. Okay. So for people who are already familiar with programming language, or you are working in a more professional environment, you probably already know what is version control. For people who don't, we need to understand. Let me bring the slides. Get a little bit understanding about what is version control. Okay. So version control, we can, there's a user interface, but I don't see any reasons why we need to bother with a user interface because the command line is pretty straightforward. Yeah. So in Linux, in Windows, you can use the command line to do those version control. Yeah, I will give you some demos. Don't worry. Yeah. So here, if you don't catch anything I'm talking next few slides, don't worry. I will show you, I play a video for you, so you will see how exactly you are going to do. But now I want to have a big picture to say why we bother with the version control. Okay. So version control is, remember you are coding on your home computer, right? But there's a server, which is, we have access. We don't have access to your home computer, right? So in order for us to get your homework, to do the grading, to check whether you are running correct, we need to access to your code. So what to do, you need to upload your code to a remote server so we can have access, okay, right? So version control, some kind of doing that, but with a little bit, or not a little bit, with something very serious extra usage. It will try to keep different versions for you. Okay, it not only just store on a remote server, but also try to keep a version. Okay, so if you don't like certain version, you can roll back, or if you can tell me, check out a particular version or something. This is more advanced things we will talk about that. Yeah. So the big picture is something like this. You have your home computer. Okay, this is your working directory. And at your home computer, there's also a stage called staging. We will talk about that. And then we have, you are, in order to using a version control, you need to create a local repository. This is another thing which will stay on your home computer. Okay. Then we will have a remote repository, which some server, but in our case will be GitHub. The GitHub will be the remote repository. Everybody put your stuff there. Okay. So you start with, you don't have anything on your computer, nothing. But on the repository, we have a version A, version B. This is some TA put maybe an empty homework there. Say this is question, this is some piece of code, but with certain function, empty, and ask you to fill in the function. Okay, so this is at the remote repository, we have something. And what you need to do first, you need to clone your remote, the GitHub. So basically we release the homework. You need to clone it first. After you clone, you will get from the latest, by default, you will get from the latest version to your working directory. So after you do clone, magically your directory will start to have a piece of several additional file appeared. Okay. Then you will try to modify. You do your homework. Okay, you think, hey, it's good. I finished my homework. So now you're ready to submit. You just try to add. You do the command add. Add, that means I'm not submitting everything from my computer to GitHub, right? I just pick a few files and I add them. Once you add them, it will enter the stage and stage. Okay, yeah, sorry. Yeah, then you can do commit. Commit is what? It's trying to say, okay, I'm ready to commit the current version ready for submission. And once you do commit, remember, you only commit to your local one. The remote one don't have anything. So this is the most confusing stage. When you have to do commit in order to say, I commit to this version. I'm ready to submit this version, but this version have not been submitted. So you have to do a push. All right. Once you do a push, hey, you are all done. We get your result. Okay. So I play a video for you. Because you are going to use this Scholar cluster. So this is Joey is our lead UTA. Honestly, I haven't played with this Scholar cluster. So some people
is and what Git is in general. So Git is a version control system, and that means that when you write code, you can specify what version of code you're writing. Then you can go back and say, I made some changes that I didn't want to do. I can go back and fix that. And Git also has the ability to sync up code between multiple machines. So if you have one machine in your house and one machine in a lab, you can use Git to grab code that you wrote on your home computer all the way in the lab. So that's really nice. Used all the time in industry. And for this demo, I'm going to actually be using the Purdue Scholar thing. It's this Scholar computing cluster. So here's the class website. I'm just going to click on Scholar computing, launch the remote desktop, and then I'm just going to sign in really quickly.
Yeah, and just to clarify too, this is great that we're doing the, Joseph's doing the demo using, do you prefer Joe or Joseph, by the way?
You can just call me Joseph or Joey or Joe. Yeah, it's up to you, man.
Showing you how to access Scholar resource that you have. But
so
you can also.
This is a web-based. Each of you suppose go back to check. I have requested your account, so you suppose each of you are able to use this. So even you don't have a home computer, don't worry, you can use this to do your homework. All right.
You get locally on your own computer. Thanks.
Yep. Thanks, Professor Princeton. That's a good point. I'm going to use it on Scholar just because it's standard for everyone. But feel free to download Git on your own computer and do it on your own file system. So Git is a command line program, so you're going to be using it on the command line. So I've opened up the terminal here, and I'm just going to navigate to this folder I've set up called EC20875, and there is nothing in this folder right now. So I'm going to.
So the ls command, if you are new to the Linux, ls is just like dir in your window. It's like to list the information in your directory. So when you do ls, you get nothing. That means this is an empty directory. Okay.
Quickly move to another tab here. This is an example of a repository on GitHub. So projects in Git are held in what's called a repository. It's a repository of code.
Yeah, for people who never touch the GitHub, this is something you will get, the github.com, and we will give you a link, which the link will give you the access to your homework. Okay, so then you just clone the URL to your local, then do your code, then you do the add, do the commit to the push. Okay.
I'll explain a little more on this later, but GitHub is a tool we'll be using where you can upload your repository to the cloud, and then you can pull it from the cloud whenever you want, wherever you want. So for your homeworks, you will be given a repository that's pre-made, and it will have some files in it. This example is not a real homework, but it has question.txt, which is a very simple math question. So we're just going to go through a really quick example of how you go about doing this fake homework and pushing it to GitHub. So first, because there is nothing in my ECU20875 directory, the repository is sitting out on GitHub, I'm going to need to use a git clone command to take that repository from GitHub and make a copy of it on my local machine. And the way you do this is by saying git clone, and then you need to include what repository you'd like to clone and where is it. The way you get that from GitHub is on your repository, you'll see this thing that is like an arrow that says code. You can copy this URL right over here. I'm going to just type it out because there's some weird copy and paste things from this virtual computer. So it's going to ask me for my username and password to GitHub. Just going to put that in. And this is just some output that you don't need to worry about. What's important here is when I type ls now, you can see that the clone command worked. So now, if I move into this folder called 20875 get example, which is the name of the repository I cloned, I can see that there's the question.txt and the README file. I'm going to try to be quick here because I know we're over time.
Don't worry, because lecture's optional anyway. So please let's make sure let's make this clear and don't rush.
Awesome,
Anyway,
okay.
you can drop off and watch this later if you want. You're not so hard to stay.
Yeah, this is from
the ls
past
command.
semester.
That means list. Windows.
It's still fine. Git clone, still fine. Windows just has some weird syntax for things. Cool. So I've taken this repository from GitHub. I've copied a local copy using git clone to bring it onto my machine. In this case, it's this machine through Scholar, but you could do it on your real computer. I'm going to just clear the terminal for this. And this is an important, we need to talk about like something that's a little confusing. At least it was confusing for me when I was first learning Git, and it's this idea of local changes and these global changes to the repository. So if I were to, so I'm just going to use ls to look over here. If I were to edit question.txt right now, in fact, I will go ahead and do that. I'm going to use Vim. You've used this in CS159. It's a prerequisite for the class. I'm just going to quickly say that it's equal to 25. I'm going to save this file. Okay, so I've edited question.txt. I've answered the actual question.
So he modified the local one, but nothing had been touched on the remote. Okay.
But if I'm to look on GitHub right now and look at the file, it hasn't changed. And this is where that idea of a local repository and this cloud global repository is important here. On my computer, this file has changed to question.txt now has the correct answer. But I only have a local copy of the repository. I'm not actually typing on GitHub right now. I'm typing on a real file on my computer. And in order to push my changes, and Git is called pushing, in order to push my changes up to this cloud repository of GitHub, I need to go through a couple steps. So the very first thing that you probably want to do is type out git status. And what this command does is it tells you what you've changed on your local machine and what has not been changed on the global repository, this cloud repository. It's kind of like a way to say, all right, this is the things that have not yet been pushed. So I type git status, and you can see it tells me that in red, I have modified question.txt, which I have, but I haven't actually pushed that up to GitHub yet right now. To push it up to GitHub, I need to do two steps. I first need to add the file, and this is called staging. And this is kind of weird because it can be a little confusing, but I'll explain it a little more in detail. I need to add the file, and then I need to commit the file, and then I need to push the file. And those three steps I'll explain in more detail as I do them. So when I type git add question.txt, what I'm doing here is I'm telling Git, the program, that I would like to include question.txt in the next update to my code, in the next version of my code. So I type git add question.txt, and now when I type git status, it will tell me in green modified question.txt. So you can see this change over here. And that's kind of weird. Another thing you can read here is it says changes to be committed, and over here it says changes not staged for commit. This is another thing that may be confusing. Sometimes you can make a bunch of changes and commit something, and then nothing really happens. Committing is the way to say this is I've written code, and now this is a version of the code. It's the way to create the new version of the code. You need to add a file before you can commit. The reason you have to do this is sometimes you want to make a commit with multiple files being changed, and Git doesn't know exactly what files doesn't want to include in what commit. So you can add the file. In this case, it doesn't make too much sense because I've only edited one file. But if you're working in the industry, you'll be editing a bunch of files. So you add something using the git add, and then you type git commit -m, and then a message. And I'm going to explain this in a little more detail. So commit, what it does is it says, this is a version of the code that I have written, and I am done editing it. This is a version of the code. The -m is a message that is included. So it's like a description of the version. So when I say git commit -m, and then I can say answered question. What I'm saying is this is the version, this is a version of the code, and an explanation of the changes that I've made since the last version of the code is that I've answered the question. I can now hit enter, and it will tell me a lot of things. You will not have this if you're not on Scholar, but don't worry about it. It just tells you who's made the changes. Now, when I type git status, the file has disappeared. The reason being is now I'm on a new version of the code. I've no longer edited this file called question.txt. I'm actually on a completely new version of the code that has this already fixed up. So if I go back and look at question.txt, yeah, my answer is still there, and we're good. But if I go back to GitHub and I click on question.txt, yet again, I have not actually edited it on GitHub.
Yeah, this is very important. When you commit, things haven't been modified remotely. So you have to do the last stage, the push. Okay.
So this is kind of weird, and it can be confusing if you're just starting out. But when you make a commit, you're only making it on your local machine. In order to tell your machine that I've made this commit and I would like to tell GitHub that I'm ready, you need to do this command called git push, and it's pretty easy. There's nothing special to it. You just type git push, and it will ask for your GitHub username. I'm just going to. Cool. It's gone through a bunch of stuff, but you don't really need to worry about it, because if we look up here, if I refresh this page, all of a sudden I will finally answer the very complex math problem.
All right. So are we comfortable with the homework? Okay. So now let me take the last 8 minutes to give you a very quick, yes, questions. This will be part of my lecture video. Yes. If I did things right. So this. If you install an encoder, okay, you're supposed to get some command like this. So what I going to demo how to use the Jupyter Notebook. The reason I want to bring this at this class is because I feel this is a really great tool. It's nothing to do, Jupyter Notebook is nothing to do with your homework. So I emphasize, this is for your own practice. Okay. So if I type Jupyter Notebook, after you install the encoder, okay, type Jupyter Notebook. When you type, you'll get something pop out in your web browser. Okay, so let me take this out. So you can start a notebook by click the new and choose a Python 3. You will get something like this. All right, so now you get an interface. You just start a Jupyter Notebook. It will automatically bring a window, a browse in your browser. And now you can start to write your Python code. This is for your practice. So like all the examples I present during the lecture, if you like to, feel free to type inside here and see what happens. But this is not for your homework. For your homework, you need to use a text edit or using a PyCharm to write the .py code. All right. So this Jupyter Notebook, what you are facing is actually two things. One is front end, one is back end. The front end we call the cell. Those things you can write your code. And the back end, there's a kernel, which is a interpreter. We are trying to understand your code, produce the output. Okay. So for example, you can write x equal to 1. And if you want to execute, of course, you can click run here. Okay. And another thing is if you are lazy, you can click this open. You can see this small keyboard. You click, there's a lot of short keys. I think remember a couple of them will make life much easier. For example, instead of every time I click the run, what I can do is I can do let's say, Control Enter, it will run. You can do ALT enter, it will run and move to the next cell. Yeah, try to play with it. It's pretty convenient. Of course, nothing output. We can print X. If I do Control Enter, it will print output. All right. So you can see, you can start to play with. This is a very nice Python player. You can play with your Python here. And actually, the reason we call the notebook is actually it's not only accept codes, it also accept markdown language. If you know what that is, like HTML or something, you can write your text in a very stylish. You can bold your later in my later demo in the class, you will see all my demo script. It looks like a report. Okay, so play with it a little bit. And in this class, also do more for things you want to learn more. For example, you want to learn more about markup language, do a Google search, and yeah, it's not part of this class, but it's very useful. All right. So any questions about this Jupyter Notebook? We know how to start. We know how to type in the class examples. I think that is good for now. So any questions? Otherwise, I see you on Friday. On Friday, we will do a lot of examples, hopefully.